Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will develop the programming for STM32 microcontroller. In the previous video, I have explained you what are the different registers we're going to use and how to understand the register bit fields and how to develop that part that I'll explain in this video. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and click on bell icon and share this videos to your friends and colleagues. Let us start the video. So guys, in the last video I have explained you about what are the different registers, what are the different ports, and what are the different registers we're going to use in order to develop the programming. So if you have not watched that video, I'll update the link in the description box and as well as in the iCard. Please watch that video as well to understand this programming. So in the previous video, I have explained you what is the AHB ENR, what is the mode register, what is the BSR, and how to set and clear. All these things I have already explained in the previous video. Now let us directly jump. So guys, this is your programming tool. About this also I have one video, how to use a STM32 Cube IDE, how to install, how to use the STM32 Cube IDE. All this I have explained in the previous video. I'll update the link in the iCard and description in the description box. Please watch that. So now coming back to the programming, so I have already set some of the basic information on this. You can see I have created one function called as a delay here. Yeah, so I have included the header file. So I have created one function called delay. So here you can see this delay function I'm going to use. Yeah, so here, as I explained in the previous video, so 4 important things we have to do. We have to enable the clock, and we have to configure the port pin as an output port, and we have to set the port pin to high, and we have to clear the port pin to low. So 4 important things we have to do in this program. So in order to do that, to enable the clock, I have already explained you. So we have to use something called as GPIO, AHB, ENR. So whatever I have shown you in the slide, RCC, EHB, AHB1, ENR. So we have to enable the clock, and this is how we're going to use. So if you want to enable the clock, here I already have created one macro. You can use that. In the previous video, I have explained you how to create this macro and why we are creating that. Okay, so you can just use this. Okay, this statement, whatever you're seeing, this is going to enable clock for your AHB, for your GPIO port. First point. Next, how do you configure port A5 as an output port? In order to configure the port as an output port, so we have to use, again I'll tell you how to do that. Again, you can see this is my mode register. You can see I'm going to use bit 5, pin 5 I'm going to use. For pin 5, 0, 1, 2, 3, 4, 5. So this bit fields we have to use. Bit number 10 and bit number 11 we have to use, and we have to configure as 0, 1. Okay, this 0, 1 is nothing but I'm just using like this 0, 1. Okay, so this 0, 1 I have to put it in a bit 10. Okay, so bit 10 I have to keep it. So now I'll do that. We have to use GPIO A. GPIO A stands for port A here, followed by, so we have to use mode register, mode R. Okay, is equal to, or directly you can put this value, anything is fine. Okay, output mode is also fine. Bit number 10. Okay, so I'm just making as a simple here output. GPIO output. So you should understand this is a macro and this is a bit position. The 10, whatever you're seeing, the 10 is a bit position. Okay, so 1 is your bit field. Sorry, mask value. This is a mask position, this is a mask value. Okay, so now what is going to happen? It's going to configure your GPIO port PA5 as an output port. Okay, this is my second step. And then in order to set and clear, so you can see the line number. So line number 16 and line number 18, you can see I'm going to set and clear the port pins. In order to set and clear the port pins, we have to use something called BSRR. BSRR stands for, I have already explained, BSRR stands for bit set and reset register. You can see here. So this is the name of the register, GPIO port bit and set reset. Since I'm using PA5, you can see here, I have to use bit 5 to set, bit 21 to clear. Set, and here it's going to be clear. I have to use bit 5 and bit 21 in order to set and clear. Okay, let us do that in the code. So GPIO I'll be using here. So GPIO BSRR bit set and reset. I need to set it bit 5. Okay, and then I need to clear it. So if you want to clear, I need to use bit number 21. Okay, so that much program, and in between you can add small delay. That's it. So you can add some around 1000 delay, you can add here, or you can add 500. Let us keep 1000. So this much is a program, very simple program, but you should understand its usage. What are the different registers we are going to use, and how to configure, what are the different bit fields. All this information you should know, then only you will be able to develop the bare metal programming for your microcontroller. Okay, so this much programming. Now I'll compile this. So this is my code. So this is a hammer symbol, whatever you're saying. This is the build icon. If there are any errors, it will show you, it will throw you here in the bottom, and you can see there are 0 errors and 0 warning. No problem. If you want, you can give one more build here. Okay, there is an error. Now let us see that what it is. Yeah, so what I make mistake is I supposed to give GPIOA here. That's why it is not, GPIO is not able to recognize. I supposed to give GPIOA here. You can see in the above I have given GPIOA, and here you can see previously I was not given. So now I'll build it. Okay, now building is done. After this, I have to flash the hex file to the microcontroller. In order to do that, you can right click on this and you can run it. I have already connected my board, so you can see here there is a run option. You can click on run, and then yes, it will take some time. So it is asking which file we want to flash. I want to flash STM32 demo. ELF stands for executable and linker file. So click on OK. Xcode into the microcontroller. Now you can see this is an LED. what I have told you, the green color LED, whatever you're seeing here on the screen, this is getting toggled, right? So observe that the green color LED, whatever you're seeing, that it's toggling, right? So in this way, you can develop your programming to the STM32 microcontrollers. So this is a board I told you. This is the STM32 Nucleo board. You can still, yeah, you can see here clearly. So I have given more delay. Because of that, it is taking time. Now what I will do, I'll just reduce the delay. Let us see what will happen. I have given around 1000 delay I have given here. I'll just reduce to 500 and let us check what will happen. So I have given 500 delay and then build it. I will build it once and then I'll flash to the microcontroller and go to run as STM32 project. So it is actually flashing. So now you can observe the toggling will happen more. Now if you observe, the toggling speed got increased, right? So like this, you can develop your GPIO programming for your microcontrollers, especially for STM32 microcontrollers, right? So this is one of the video, one simple program. In future, I have a plan to produce some more videos on this STM32. So please click on like button and subscribe my YouTube channel. Click on bell icon and share these videos to your friends and colleagues. So we'll meet you in the next video.